So today we're going to look at how to graph in standard form. Just a quick recap of key concept. The first is that the axis symmetry is a vertical line, negative b over 2a, x equals negative b over 2a, and that the vertex is always going to lie on that axis of symmetry. Right, we're going to use that. These were the steps we talked about in the beginning of chapter 7. Right, we talked about how we're going to find that negative b over 2a. We're going to take that in, plug it to find our vertex. Then we're going to find 2 points either to the left or right and use that to graph the parabola. So if you need to revert back to these steps, feel free at this point in the video. We're 40 seconds in, so go back to 40 seconds to view the steps. So I'm going to start with this problem here. We only have 2 problems because usually these are a little lengthy. So remember, to start with, we're going to name our A, B's, and C's. Our A is -1, our B is 4, and our C is -1. So we're going to utilize those features for the rest of the example. So I'm going to first plug into negative b over 2a. All right, when I do that, I get x equals -4. Pay attention, that negative from the formula stays there, and now I have a 4 over 2 times -1. When I do that, I get -4 divided by -2, which simplifies to a 2. So on the value for x equals 2, I'm going to draw a vertical dashed line, because remember, it's imaginary, it's not actually there, it's just used for our symmetry. I'm going to draw a dashed line through x equals 2. So right now we know that it's going to be symmetrical on either side of this line. So I'm going to take that x equals 2 and plug it into my original x's into the equation. So I get y equals negative blank squared plus 4 blank minus 1. And the value you just found here is going to go into those blanks, 2 and 2. This is the biggest mistake that people make. All right, please pay attention to this first step. You have to follow PEMDAS, meaning you do the exponent first. Exponent needs to come first. So when I do this, I do 2 squared, which is going to give me a -4 plus 8 minus 1. Simplify this using PEMDAS. It looks like you're going to get a 3. So that means I plugged in a 2, I got a 3, and this is going to represent the vertex. So I'm going to plot that, and you're going to notice that vertex has to lie on the axis of symmetry. So everything branches from here. Now before I go on to step 3, which is finding 2 points to the left or right, pay attention to which way you think this is going. The A value is a -1, meaning that if it's -1, this should face down. So we're going to look at plugging in 2 points. I could either go to the right and plug in 3 and 4, or I can go to the left and plug in 1 and 0. Personally, I think it's easier to plug in 1 and 0, so I'm going to go ahead and plug in 1 and 0. Let's start with 1. When I plug in x equals 1, I'm going to get y equals negative blank squared plus 4 blank minus 1, which is y equals -1 squared. Let me not rewrite this. Probably easier if I just throw in the ones here and here. So I've plugged in this x value equal to 1 into my 2 spots. Now I'm going to simplify using PEMDAS. Remember, exponent first. So that can give me y equals -1 plus 4 minus 1, which really this is just a -1, so when I simplify I get 2. So I plugged in a 1, I got a 2, those are coordinates of the point, 1, 2, I can plot them. So I have a point at 2, I have a point at 1, now I'm going to get one more point at 0 somewhere on this y-axis. So I'm going to plug in x equals 0 and do the same exact thing. Y equals negative blank squared plus 4 blank minus 1. Put in the zeros. This is just going to be 0. That's going to just be 0. And I'm left with y equals -1. Which means I plugged in 0 and I got a -1. So I plot that. And you can see this left side of the graph forming, right? Well, now all I have to do is take these points and go symmetrical over the axis to here. So there's a point here, and I'm 2 away from the axis here, so I'd be 2 away from this side. And now we have that upside down U shape because the A value is negative for me to graph. And that's how we're going to graph in standard form. Let's look at one more example. If you feel comfortable, feel free to jump to your homework now, but I'm going to do another one where it faces upward. So this one, I'm going to start by writing down my ABCs. A is equal to 2, B is equal to 4, C is equal to -5. We're going to go through the process again of plugging in when x equals negative b over 2a, which gives us our axis of symmetry. That's negative 4 over 2 times 2, which is really just a negative 4 over 4, which is a negative 1. And now I'm going to plot that on my x equals 1 axis of symmetry. You can see it right here as a dashed line. Now to find the vertex which lies on that is going to be plugging in -1 into our function. Remember, we're going to square first here, which gives me a +1. This is a -4. That's a -5, which really gives me 2 minus 4 minus 5. And this is going to just give me a -7. So I plugged in -1, I got a -7, and that's going to represent my vertex all the way down here at the very bottom. So now what I have to do is plug in 2 more points. Remember, I'm at -1, so I can either move to the right, which is 0 and 1, 1, or I can move to the left, -2 and -3. I'm going to plug in 0 and 1. Let me move this over for you. Going back to a previous example, if I plug in 0, right, these cancel, I'm left with y equals -5, so I got 0, comma, -5. Plot that on here. Now when I plug in 1, I have to do a little bit more PEMDAS. Exponent first, 1 squared is going to be 1, so I really have 2 times 1 plus 4 minus 5, which is 2 plus 4 minus 5. And if I simplify that, it looks like I get a 1. So when I plugged in 1, I got a 1, and I'm going to plot that point now, 1 comma 1, which is here. And again, I only have half my graph, so I have to take it and reflect it to the other side. So if this is 1 or 1 away from the axis, and this is 2 away from the axis, I can plot my points. And you're going to notice this graph is a little bit more skinny than the past one because my A value was 2. You're also going to notice that our graph is facing upwards because our A value is positive. And the last thing that you've probably noticed is that when I plugged in 0, I got the C value, which is the y-intercept. This will always represent the y-intercept. So that's a free point you can use if you want to look at your graph. It goes through at -5 and go back to my previous example. Right, my C value was a -1. Well, look at where it crosses the y-axis at -1. So it's something you can use as you go to your homework. Remember to scroll down to the bottom for the answer key. Email us if you have any questions.